procedure. So for this chapter, we are kind of like repeating what we learned, but the difference is now we are the knowledge we're going to learn from this chapter allow us to analyze a more complicated situation. So actually, your final project is related to the multiple regression model. So before we look at anything new related to multiple regression model, I want to revisit our this flowchart again, help you to connect the concept we learned. So in chapter 14, we are focused on simple linear regression model. So we already learned, and you understand the procedure we have to go through. And in chapter 15, and actually you're going to notice that we are going to going through the same procedure. The only difference is we're going to look at a multiple linear regression model. So that is what we're going to cover, multiple linear regression model. So in this introduction video, my main job will be help you to look at what we're going to learn in this chapter 15. So chapter 15, I didn't separate into two parts. The main reason is because I just want to let you understand that every procedure we need already learned in chapter 14. So when we are learning in chapter 15, we only focus on the differences, so which means we have less new information gonna obtain from this chapter 15. So that's why I didn't separate chapter 15 into two different chapters. So therefore, this week, when we are learning chapter 15, pay attention on comparison, comparing chapter 14 with chapter 15. And during the lecture, I also will emphasize the similarity and the differences between simple linear regression model and multiple linear regression model. And as I said, the analysis procedure will be the same. That's why we're going to revisit our analysis procedure again. So for the regression analysis, no matter simple linear regression model or multiple linear regression model, we're all going to go through these 6 steps. Decide variables, describe the descriptive statistic, mean, median, mode, standard deviation, skewness, etc. And then draw the scatter diagram, try to decide if our functional form, we assume a linear function form can be a whole for the model. And the 4th step is obtain the regression model. And the 5th step is using the model to do the prediction. And the last one will be the diagnostics. So in this chapter 15, similar to chapter 14, we only focus on step number 4 and 5. So we're going to look at how we're going to obtain the multiple regression model. And we're still going to go through 3 sub-steps. So estimate the regression sample model, and then testing the quality of the sample model, and then we're going to test in the quality of the population model. And after that, we can prove if we have a good model that can be used for the prediction. So if that's the case, and now we can move on to step number 5, and we're going to use the model to do the forecasting and estimation. So in chapter 15, we're going to look at step 4 and 5. And what is a multiple regression model? So in this chapter, we continue our study of regression analysis by considering situations involve 2 or more independent variables. And this subject area is called a multiple regression analysis. This enabled us to consider more factors and thus obtain better estimates than are possible with a simple linear regression model. So if you think about what we learned in chapter 14, so that equation y hat equal to b0 plus b1x. So on the right hand side, we're only including one factor. So but if you look at a y, so for instance, why Walmart's revenue go up next month, there are so many factors contribute to that result. So if you only look at a simple linear regression model, you only can consider one variable at one time. So obviously the model itself is pretty weak. So in order to make up the weakness of the simple linear regression model, that's why we are able to develop this new method. It's called a multiple linear regression model. So on the right hand side, instead of only one x, now we actually can include as many x we want. So those x, if you are thinking, the factor can affect the y, so you should include. So let's look at how our multiple regression model look like. Similar is the like I said, we're going to comparing the simple linear regression model with the multiple regression linear regression model. So similarly, we're going to look at 3 equations. So the first is a regression model. The second one is population regression equation, and then the last one is the one we're always going to work on first. It's called estimated multiple regression model. So what you're seeing here on the slides is called the multiple regression model. So what we are trying to use this model picturing is the dot. If you're thinking about the two-dimension model, the simple linear regression model. So that specific scatter. So we try to measure in that special scatter. So that's why we are having that arrow term at the end, epsilon. So you notice that all the parameter symbol is a Greek letter because this is for the population model. So this is the ultimate goal we try to obtain. So y equal to beta 0 plus beta 1 x1 plus beta 2 x2. So you can notice the differences between simple and multiple linear regression model. So if you look at it, if I will cover this part, if I delete those pair of the beta and x, and you notice that this actually is our simple regression model, right? Simple linear regression model we saw in chapter 14. However, now we're actually extending what we learned from chapter 14, so we are including more factors. So think about the first example I mentioned about the size of coffee shop. Based on knowledge we learned in chapter 14, we only can consider one variable, maybe just the budget. But now we have the multiple regression model. So x1 will be my budget, and x2 will be the potential customer, and x3 can be considered as either have drive-through or non-drive-through, and x4, etc. You can add in many factors as you want. So this is called a multiple linear regression model. So before we move on to look at the equation, and I want to ask you the name of each parameters. So the beta 0 we learned in the simple linear regression model is called y-intercept. And the beta 1 we learned in the simple linear regression model, we call it slope. However, as we move to the multiple linear regression model, we no longer can call beta 1, beta 2, beta p as our slope because you won't be able to distinguish which beta you are talking about. So therefore, the best way to call the beta will be partial coefficient. So partial coefficient. Why I'm emphasizing this name, partial coefficient? So let me write it down. What is the... So let's look at this term is called the partial coefficient. So why this term can be used to distinguish different betas? So let's go back to look at the slides again. So the x1 had beta 1, so we don't call it beta 1. We call beta 1 as partial coefficient of x1. Partial coefficient of x1. And beta 2 will be partial coefficient of x2. Partial coefficient of x2. So let me write it down. So, like I said, beta 1 partial coefficient of x1. And depends on the real name of x1, you can replace x1 by the real name of the variable. So for instance, x1 is the budget. So then beta 1 will become will be called as partial coefficient of budget. And so the beta 2 will be the partial coefficient of x2. So beta 2 is called partial coefficient x2. So for instance, if x2 is the number of the customer, so then the beta 2 will become partial coefficient of the number of the customer. So we no longer call beta 1, 2, 3 as my slope because we won't be able to distinguish which beta we're talking about. Instead, we should use the partial coefficient. So why am I emphasizing the name of the betas? Because after you finish your experiment 3, you notice that all the regression analysis question I require to interpret your results, and you have to understand which beta I'm asking you to interpret, especially during a test. So we don't have enough, we have limited time, so I won't ask you to interpret all the betas. So instead, I only pick up 1 or 2 importance that partial coefficient to ask you to interpret. So in order to know which one you're interpreting, you have to know the name of the betas. So that's why I'm emphasizing the name of the betas. So beta, except beta 0, we still call it a y-intercept. So the rest of the betas, we call it partial coefficient of x1, x2, or xp. And the reason we call it partial coefficient is because beta is measuring how x1 connect with y. Beta 2 is measuring how x2 connect with y. So that's why we call it partial coefficient of x1. So keep in mind this is very important, and because this is a very different from simple linear regression model. So this is the first model equation we saw, very similar to simple linear regression model. So the next equation we see is called multiple regression equation. So this is still for the population. So the difference is we no longer have that arrow term at the end of the equation. So we no longer have the error term at the end of the equation. And also on the left-hand side, we become expected value of y. So what we try to model on here is the trend line in the population scatter plot. So the trend line in the population scatter plot. And so both the equation won't be able to estimate directly because usually we won't be able to have the population data. So in order to estimate to understand how in the population, how x and y are related, and we're going to rely on our sample. So that's why this is the third equation we also see in the chapter 14. So called the estimated multiple regression equation. So on the left hand side is called a y hat. So y hat is our estimated y value and equal to b0 plus b1x1, b2x2. So the b is here also called a partial coefficient. B1 will be partial coefficient for x1, and the B2 will be partial coefficient for x2. So when we look at the next video, we're going to look at first step of obtaining a regression model. And so you notice that actually we're starting from this model, and very similar in chapter 14 because we're always starting from the sample. So one more time showing you this rationale of this analysis. And so this is our goal. We try to obtain the information about population. However, we won't be able to do that. And so in order to directly get all the value for your population, we actually using the sampling method to collect the sample data. So collect the sample data. So the sample table is supposed to be able to represent your population. And then we apply the computer software and then obtain our estimated regression equation. And then we're going to using the test the significance to prove if our sample beta can be used to representing the population beta. And then if that's the case, and then we went through a detour to obtain the relationship between x2, x1, x2, x3, etc. with the y variable, and then we can go further to do the prediction. So in our next video, what we're going to look at is how we carry on our first sub-step under obtain the regression model.